Welcome back. This is all about properties of real numbers. This video is not super computation heavy. It's mostly concepts, so I'm hoping to be pretty quick with it. Okay, we're going to be able to classify real numbers, use the properties of real numbers to evaluate expressions, and rewrite radical expressions as integers with radical exponents. So some vocab, since it's a content heavy lesson, it'll be a vocab heavy lesson as well. This should be familiar to you. Real numbers, when we talk real numbers, we just mean any number that is real. And up to this point, all the numbers you've seen are real. We will get into imaginary numbers later in the year. Real numbers have subsets. So rational numbers, irrational numbers, integers, whole numbers, and natural numbers. Rational numbers and irrational numbers, it's the first major division. So you've probably seen this type of diagram before. And on the left side we have rationals, and on the right side we have irrationals. Rationals are anything that can be written as a fraction or decimals. Another common definition is decimals that terminate or repeat. Irrational numbers have decimal forms that neither terminate nor repeat. So some examples of irrational numbers are pi, square root of 2, the square root of a lot of other numbers as well that are not perfect squares. Those end up being irrational, okay? And then from here on out, we're going to divide the rationals up into subsets. So the next major division, we have our integers, which are, I like to think of them as number line numbers. So 0, 1, 2, 3, 4, 5, 6, all the way up, and then their opposites. So -1, -2, -3, -4, etc., etc., okay? And then the subset within the integers is our whole numbers. And then this diagram doesn't have an extra circle here, but there should be another one here that would be natural numbers. The only difference between whole numbers and natural numbers are that whole numbers include 0 and natural numbers do not. Okay. Some properties of real numbers to be familiar with. This is pretty language heavy, but the big picture, there are 6 major properties of real numbers, and they each exist for addition and multiplication. So addition and multiplication are special operations in math because these are true about them. They're commutative, meaning you can change around the order without changing the value of the expression. They're associative. The best way I can paraphrase this is that you can regroup by moving parentheses around and you will not change the value of the expression. They have an identity property, which means if you add 0 to a number, like 1 plus 0 equals 1, that's true for all real numbers. Adding 0 doesn't change the value. Its identity always remains the same. And then the identity for multiplication, anytime you multiply a number times 1, the number stays the same. Inverse, if you add opposites, so like -2 plus 2 gives you 0, they undo each other. That's the idea of an inverse. And then with multiplicative inverses, we have like reciprocals. So the reciprocal of 3 is 1/3 because if we multiply them together, we get 1. Okay. Closure, this will be important if you ever study mathematics in college. Closure is if I add 2 real numbers together, then the result will be a real number. If I multiply 2 real numbers together, I will get a real number. And then distributive, the distributive property of multiplication over addition just says that if we have something like 2 times the quantity x plus y, we can distribute the 2 to each item in parentheses. Okay, so those are some properties of real numbers. You've probably heard the names, and they should be familiar to you. What we will use the most is commutative and distributive. So here's an example. Name the property illustrated by this. So we see there's multiplication, so we know we're going to be talking about one of our multiplication properties. And notice how what we're doing is moving around the parentheses, and we're not changing the value of the expression. So because we're moving around those parentheses, we're kind of regrouping. This is our associative property of multiplication. That looks like, okay, multiplication. Okay, because we're regrouping, we're not changing the value, it's associative. Okay. Find the additive and multiplicative inverse for -5/8. So additive, the question we want to ask ourselves when finding an additive inverse is what number, if added to this, will give me 0? So -5/8 plus 5/8 will give me 0. So its additive inverse is 5/8. Its multiplicative inverse, I'm going to abbreviate multiplicative. Multiplicative inverse, think about what number, what if multiplied by -5/8 will give me 1. So typically it's going to be the reciprocal. In this case, we also want the negative reciprocal because we want negative 5/8 to become positive 1. So we need to multiply it by a negative reciprocal. Okay. A couple more examples. This is sort of related, but also kind of different. It relates to real numbers. So when we have a fraction and an exponent like this, the way I like to remember it is BLTR. This is how my high school math teacher helped me remember it. Like bacon, lettuce, tomato, ranch, BLTR. The ranch is normally not on a BLT, but in this case it is. So what this means is bottom, left, top, right. Bottom, left, top, right. So if we want to rewrite something like this as a radical, in radical form that can be simplified, bottom, left, so the 2 is in the bottom, that's going to become my index of the radical. And then 16 is what's being taken the square root of. And then top right, that's the 3, that's the top number in my fraction, that goes on the right side. So it's like I'm taking the square root of 16 and then I'm cubing it. This is also equal to taking the square root of 16 cubed. So you can either cube it before you take the square root or after, it doesn't matter. If you simplify this, the square root of 16 is 4, and then 4 to the third power gives us 64. Okay, so we will talk about that more when we get into rationals, but it's something I want to preview now since we're talking about real numbers. And then going the other way, if you want to rewrite this as an integer with a rational exponent, we're going to have 8. And then thinking about BLTR, bacon, lettuce, tomato, ranch, bottom, left, top, right. So the left number goes on the bottom, and the top number goes on the right. Okay, so 8 to the 4/3 power is another way to rewrite this. Okay, that's all for now. Take a look at your practice, and we will discuss any questions you have.